True peace, Ken's 3D Nano Ink push industry boundaries. Man, peep the slang. This just came out today. A new 3D printable polymer nano composite ink has incredible properties and many applications in aerospace, medicine, and electronics. Man, peep the slang. Mechanical engineering researchers at Michigan Technological University have created a way to make a 3D printable nanocomposite polymeric ink that uses carbon nanotubes, CNTs, known for their high tensile strength and lightness. This revolutionary ink could replace epoxies, and understanding why its properties are so fantastic is a first step towards its mass use, man. Peep the slang. 3D printing, also known as additive manufacturing, is more versatile and efficient than casting. It adds a material with precision, often in complex geometries with considerable less excess to cut away, adding low-dimensional nanomaterials such as CNTs, graphene, metal nanoparticles, and quantum dots allows 3D printing materials to adapt to external stimuli, giving them features such as electrical and thermal conductance, magnetism, and electrochemical storage. Man, people slang. But 3D printing using plastic, metal, or something else entirely isn't new. What tech researchers have done differently is use polymer nanocomposites made of epoxy, carbon nanotubes, and nanoclay, and a printing process that doesn't sacrifice functionality. The junction of material type and morphology, size, shape, structure in polymer nanocomposite ink is the ultimate in form meeting function. Man, peep the slang. The exploration of process, morphology, and properties of polymeric ink is the subject of an article recently published in the journal Additive Manufacturing by Parisa Pour Shahid Saeed Abadi, an engineer who explores the interfaces of materials, mechanics, and medicine, and graduated student Masoud Kasarai. Kasarai. Abadi and Kasarai point out that before researchers can sprint off to the races using polymeric ink, they must first learn to walk. The first step is digging into the intersection of the macro scale, how our eye sees a material performing, and the nanoscale, what we can't see but is occurring. Peep the slang, building understanding before market share. While polymer nanocomposites and 3D printing products services both have billion-dollar market values, nanomaterial 3D printing only has a market value of approximately 43 million, Abadi noted. Nanoparticles, man, peep the slang. For national prosperity and sustaining global leadership in manufacturing, the gap between the real world applications of 3D printing and nanomaterial versus nanomaterial 3D printing needs to be closed, Abadi said. The gap isn't due to lack of control of nanocomposite properties in the 3D printing process because we don't fully understand the process, morphology, property, relationship, man. Peep the slang. The bottleneck is understanding the complex interplay between the micro scale mechanics of 3D printing processes and the nanoscale mechanics and physics of nanocomposites. Abadi and Kasri's research seeks to loosen the bottleneck by exploring the relationship between 3D printing process and perimeters and nanomaterial morphology and nanocomposites printing inks, which is the most important but least explored piece of the puzzle, man. Peep the slang. The many benefits of nanomaterial ink. Moving beyond the science of nanocomposite ink, the material holds great promise because of its many functions. One advantage of 3D printing is near complete control over the final product shape. The, the conductivity of Abadi and Kasari's nanomaterial ink is an exceptionality handy trait that gives the printed epoxy the potential to double as electric wiring, whether in a circuit board or an airplane wing or 3D printed actuators for guiding catheters in blood vessels. Another useful trait of the nanocomposite polymer ink is its strength. The comparison with steel and aluminum, we see 80% weight reduction with the epoxy composite, the same strength, man. People slang. Finally, in the medical field and aerospace and electronic industries, where defects and damage can spell a big problem, the nanocomposites serve a safety function, man. People slang. When something breaks, a tiny crack starts from a micro scale defect and progress until it breaks the entire structure. Abadi said nanocomposite features make bridges in those cracks and don't let the cracks grow. This is one of the mechanisms through which carbon nanotubes increase the mechanical strength of the material. prosperity to rate ratio, electrical conductivity, increased strength, and ease of the application are just a few of the many promising reasons why polymer nanocomposite inks will likely replace traditional epoxies. Man, peep the slang. Polymeric ink, nanoparticles. True. Peace, King.